We covered earlier in the chapter how to place ellipses, and what you have here is a horizon line, an ellipse, and a square around it. So what we want to do is we want to build a spiral staircase out of this. To get a spiral staircase, what we're looking at is we have the need to divide the ellipse. So we have to divide it, and what we're looking at is a circle that is on the ground, and we want to subdivide it. Easy divisions are always the 45-degree divisions, but we want to actually have a total of 16 elements. So one is the things to divide, and the other one, what we need to do here is we need to transfer scale. So this is scale in perspective. And how to transfer scale in perspective we covered on page 53. So if you think about this, the spiral staircase is a combination of both. So first we need to divide the ellipse, and then when we have divided the ellipse enough, or the circle, then we need to transfer the height of each of these steps in perspective. So we're going to take this one step at a time, and we're going to start off with the division of the ellipse. The easiest way to approach this is to actually create a picture plane, which we looked at in earlier chapters, and in the picture plane dimension are transferred 1 to 1. So we basically take the circle out of perspective and flatten it. It is not completely necessary that we need to build the whole circle. Half a circle will actually do for our exercise. So we mark down, we transfer the width, or the radius of the circle, bring this to one side, bring this to the other side. I am marking now the base of this. Just make sure that you have enough of a line when you want to find 90 degrees or be perpendicular. I want to first just test the methodology that I will show you how to divide the ellipse. So we know how a 45-degree cut through the ellipse should look like. So that will be diagonal to diagonal. The way this works is we project up at 90 degrees wherever this line crosses the circle into perspective and find this point on the line. So if you look at the construction we have a little bit here on the side, what I want to do is I would like to draw a line into perspective that hits just those 2 points perfectly. So we're drawing this line across, so we get that. And at this point we should be able to connect these 2 points, and this should build the diagonal. So that shows me that this technique actually works. So we can transfer the point into the picture plane, project it onto the baseline, and then draw a line across. So this is the point that we were looking at right here. I can do this the same for the other direction. And then we have the subdivision in half. and we have divided it into now 1, 2, so 8 subsegments. So now we need to divide it again. And what I know is this here was 45 degrees. So half of 45 degrees will be 22.5. So I'm going to mark this distance onto the page. I'm going to use the protractor that's included in this triangle. You see it's 22.5 degrees. I'll mark this line out, and I just need to go exactly to the end of this circle, transfer into perspective, go to my one point center vanishing point, and find those 2 points, which let me divide the ellipse now into 16ths. And I'm just going to continue the process for the other side too. So I'm looking again for 22.5. Mark the point, transfer it into perspective. And we get the 2 intersection points again. So when we started the drawing, I said we only need half of the circle. But as you can see now, we actually only need a quarter of it. That's enough because we can transfer the dimensions over to the other side really easily. This technique can be used as well to find any arbitrary point. So if I wanted to find just an arbitrary point here, I'm not going to draw this in because we continue with the with the construction. If I start up here and want to find this point in perspective, I would expect it somewhere here. So you would transfer it over here and then bring it to the vanishing point, and you would find this point here. So you can subdivide anything, any ellipse, in any categories that you want. Now if you look at the earlier pages, what you will see is, if I turn this around, that this construction actually would work as well for a wheel or a rim, and you could now put spokes into the system. So this is a very, very flexible method. You just need to make sure that you find the correct or a line that you can transfer the dimensions to, and then bring it back to the vanishing point. So let's shift the whole drawing downwards. We don't need this construction any longer because we talked about the 2 steps. First we needed to divide, and we divided in 16ths, so that's done. So now the next thing is basically building scale and perspective. How can I draw something at a certain height here and make sure it's the same height here and it's the same height here? To do this, we need to first figure out a height in the first place. So what I'm going to do is, I'm assuming that there is a stick in the middle of the spiral staircase. And I just need to have an even spacing. So I'm going to take the multi-divider and mark off my even spacing. So that would be the height of the first step, here would be the height of the second step, and here would be the height of the third step. We can just mark off, and for good measure, another one, a 4th step. Now in perspective, this is really hard to see, where I'm just going, how do I know now this height here in perspective, how would it show up at this point? And what I need to anticipate is, I will not only put a line in here that needs to be correctly scaled in perspective, but there will be another line sitting right here, and it will have exactly that same height. The best way to do this is if we can actually draw a wall outside of our construction, and say, well, if we transfer all the heights to that wall and then bring it back in, that would be the easiest way to take care of all these steps. So let's just start off with the first step and transfer the height to this wall. So where does this wall exist? This line is arbitrary. I just decided where it's gonna be. I just wanted it to be far enough out so it will not interfere with my drawing. But the intersection point matches up because this is parallel to the horizon line and this line is parallel to the horizon line too. So there's only one position for this. But you could have drawn it out further. That would be okay as well. To find the same height in perspective on this stick, and I just want to call this half a foot tall, you will just basically draw a line out here. If you just want to double check this, again, page 53 will explain the principles again. Then I would like to know how tall the stick would be, and what I will do is basically take that stick, transfer it over here, and we do exactly the same thing we did here. We transfer it over, and then we move it up vertically. Look for the intersection point and bring it back. A little bit further. I just stopped a little bit short, which will show you that this is really partially a concentration game. You really need to stay on top of it. So what I found is that this stick here has exactly the same height as this stick here. Now, it's the same height in perspective, so if I take a piece of paper here, I mark that stick off. So this is the height. And I bring this over here, you will see it is actually larger. And that's because it is closer to us, so it appears larger. So now you see that actually the scale moved over correctly, and you see that this is the same height as here. Let's do the same thing for the next stick, and we can expect that it should be actually somewhere in between those two, not halfway in height, but somewhere in between. So I'm gonna transfer this as well to the wall. Place a vertical line in here and find the same transfer point here. And close it up here. So now I have found my second stick. To prove this again, well, this was the largest stick physically. Then this is the next one. It should become shorter because it moved back in perspective. And this one should be even shorter than all of them on the page. Which will now give me the opportunity to connect all of them. And what we get is our first step upwards. Now this was for one step, so we need to find the next step, which would be at 1 foot. And what you will find is we'll have to transfer that dimension again. And since I'm anticipating that I will do this for quite a couple of runs, meaning this is 1 foot, then I will do this for 1.5 feet. And potentially for 2 feet. So this was 1.5, and this would be 2. It is not essential that you draw the lines all the way across. I did this for sure so we see it here in the demo. But if you transfer all the lines across, it will get really, really crowded with lines. So you decide yourself where you feel the most comfortable to transfer the lines and how they work best out for you. I will leave some lines out. You can definitely observe in the book where they are. But this will give us a pretty good way to look at these lines. So as you will see on page 77, we will now build the next step. The next step should be now at a height of 1 foot. There we go. That's where this stick is. Now we need to park another stick at 1 foot height right here. Basically it starts here on the base. We have already half a foot. We just need another half on top of it. You can go two ways at it. You just could take this dimension that we have here and add it on top of it, because we would be moving in a picture plane. The other version is to make the full construction and bring it up to that 1 foot line on the wall relative to the base of that stick. So we're going up, extend the stick high enough that we can transfer the dimension. And we bring this over. So here's our 1 foot stick at the beginning of the stair, so this will be the front wall of that stair. And to get the platform, we need to go to the far side, transfer the dimensions, find again the 1 foot line, and bring it back towards the stick. So here we have the next step. Now we're going to quickly build out the next two steps. So, cleaning this up, you will see that we now combine those two techniques that we have talked about earlier on. What we have is, first we were able to subdivide the ellipse, so we did the subdivisions of it, and then we used the scale in perspective to find out how tall these stairs are. And each of these steps are 3 lines that have the same height, with this sitting differently in perspective. So here are the 3 lines, here are the other 3 lines, and here are the other 3 lines. So just go step by step, and to make it easier on us, we knew where it is in the middle, and then we transferred out the height, and we know how the height actually behaves in perspective. You can use this technique for building exteriors or interiors or street scenes. So if you would think of this being a house or something like that, you could actually have a pretty small person here and work with this. So it's a super helpful technique. In the next couple of pages you will actually learn how to shortcut this method. There are a couple of nice shortcuts to basically get quick division by 5, or to just indicate a thread that rolls away. And be aware that this technique, as we showed it beforehand, it works sideways too. So in any kind of direction in the perspective, as long as you find the line that you can transfer it from, you can subdivide the ellipses.